All right. So in this example, what was the key here? Because I gave you a what? A radical. I gave you a radical, but this is called the power rule, right? This is called the power rule. And essentially, we used what concept from Algebra 2, really? What's the concept? What's the rule? So the square root of x to the half, but let's generalize it, okay? So it's really simple. The nth root of x to the m power, okay? The nth root of x to the m power is really just what? X to the m over n. So whatever this exponent is versus whatever root this is, you can create any exponent as a rational. It's called a rational exponent. Rational means fraction, right? So it's a rational exponent. So that's all I did. I said, look, I had the square root of x. I turned it into x to the 1/2. I had 9 cubed root of x squared, so I turned that into 9x to the 2/3 power. And then I had minus 2 over square root of x to the 5th root of x squared. So that became a negative 2x to the... Why was this negative 2 over 5? Because the radical was in the denominator, right? So in order for me to take it, I have to bring it up to the top, which means take the reciprocal, flip it. And then at that point, I just did my power rule, right? Move my exponent to the front, subtract 1 from every exponent. So I got this second line here, 1/2 x to the negative 1/2 plus 6x to the negative 1/3 plus 4/5 x to the negative 7/5. But then, again, we ran into what issue? I never want negative exponents. So how do I fix it? I take them back. And notice, not only did I take them back, but I also did what? Put them back to radicals. Why? Why did I put them back to radicals? Because that's how the question was, right? The question was in radicals, so then I'm going to answer in radicals. If the question was in rational exponents, I could leave it in rational exponents, right? We good with that? Okay. So, I think we had example E. We had h to the x. This says x to the what? Pi power minus x to the square root of 2 power. X to the square root of 2 power. Okay? I gave you this problem because it's actually a really simple problem, but students get confused. Okay? First of all, what do I know about pi? It's a constant. It's just a number. It is not a variable. And that's when most students get confused, because they're like, oh, well, he never showed us how to do it if there's a variable in the exponent. It's not a variable. It's a constant. So I'm going to do exactly the same thing. So my derivative, what would I do with this pi? Bring it to the front. So it's pi x to the... Yeah, so, I mean, I don't want you to estimate and say 3.14 minus 1, right? So leave it as pi minus 1. Okay? And then minus, same thing with this. Actually, do y'all realize that the pi and this number are exactly the same? They're both what? Does anybody know what these kind of numbers are called? They're both irrational numbers. Irrational numbers are numbers that are decimals that never end, that don't have a pattern, right? For instance, like pi. But actually, any square root that's not a perfect square is an irrational number. Okay, so it's the same thing. I want you to do the exact same thing. So what would you get? Square root of 2 x to the... That's it. That's simple. That's simple. Okay? That's it. Can't do anything else. I can't simplify at all. Essentially, guys, what this example shows me is that does it matter what my exponents are, what my variables are, or what's there? No, it does not matter. I could give you this and say take the derivative of it, and you'll be able to. How? What would if I told you f of x is equal to x to the happy face power? What's its derivative? Happy face x to the happy face minus 1. Simple as that. That's the rule. You got to remember, guys, these are all just symbols. They're just symbols. They're symbols that you associate with a number or a value, but they're symbols nonetheless, right? So as long as I don't care what the symbol is, I'm going to apply the same rule to all of it. Any questions on that? Very, very simple. All right, so that's like the intro to the power rule. Now let's get to the good stuff. How do I apply it? Because you got to remember, this AP test is not going to be a list full of equations and say, here you go, take the derivative of it. Good luck. No, no, no. All of them are word problems, right? They make it just like your tax test. They're word problems. So not only do they want you to take the derivative, they want you to oh wow, I said tax, right? That's the last thing that I really taught. Like I haven't even touched star algebra 1, so don't even worry about that. So they're not only going to ask you to take the derivative, they're going to ask you to apply it somehow. Okay? So here we go. It says find the derivative of y equals 3x squared plus 5x minus 1, and write the equation. Write the equation of the tangent line to the curve at the point 1, 7. Okay? Write the equation to the tangent line. Of the tangent line to the curve at 1, 7. Okay, I added, there's a hint for you, okay? So how do you write an equation of a tangent line? It's actually pretty simple. Okay, the equation of a tangent line, I have a formula. Y equals f of a plus f prime of a times x minus a. Okay? Does this kind of resemble anything that we've ever seen before? What is it? Kinda. This is actually, do y'all notice that this is actually, yeah, so exactly what you said. Y'all remember the point slope formula? The y minus y1 equals m times x minus x1? You guys remember that? Do they look similar? A little bit. Don't y'all see that this is this right here? Right? And then the only thing is this is positive now on the other side. So these are the same things. Now, I have a f of a, and then here's something interesting. F prime of a. Right? What does that mean? This is a derivative of f at point A. Right? The derivative of f at point A. And what did I tell you earlier that the derivative stood for? The slope. So do you see how it's the same thing? It's in the same position here as my m, correct? Right? So these are actually the same thing. We're still finding slope. Okay? So I have everything I need. It says, look, here's their equation, y equals 3x squared plus 5x minus 1. Take the derivative of it. So let's do that first. So y equals 3x squared plus 5x minus 1. Okay? What's the derivative? 6x plus 5. Okay, so that's my derivative, correct? Okay? It says here, f of a. What does that mean? What does f of a mean? You plug in x. What's my x? 1. But, so do I have to plug in 1? Why? If I plug in 1, what am I going to get? 7. I already know. That's what this means, right? That's what every xy coordinate means. It means when you plug in x, this is the y you're going to get, correct? So I can call this point a, and I can call this f of a. Does everybody agree with that? Right? When you plug in your a to the function, it's right there. So I know a is 1. I know f of a is 7. And looking at this, what else do I need? The f prime of a. So how do you think I find that? Right? So it's plugging in here. So in our case, f prime of a is f prime of 1, which is what? 11. Does everybody see how I got 11? Right? You plug in 1 here. 6 times 1 plus 5 is equal to 11. So f prime of a is equal to 11. So look, do I have everything I need? Right? Do I have everything I need to write an equation? Very simple. Okay, so I'm going to use this right here. So my equation is y equals what? 7 plus 11 parentheses. So remember, when you write an equation of a line, it's like normally y equals mx plus b. So there should be a y and there should be an x. So that's this x. That x stays. Okay, so that x is going to stay minus 1. Now, does that look like an equation of a line to us? Not really, right? Because like I said, we normally want to see it in y equals mx plus b form. So how would I get this into y equals mx plus b form? Distribute and simplify, right? So I would get y equals 7 plus 11x minus 11. Y equals what? Write it in the right form for me. 11x minus 4. Is that better? Is that an equation of a line? So this is what? What does this represent? This is an equation of the tangent line. And I want to say something very specific. At x equals 1. So this is the equation of the tangent line at x equals 1. And now I have to kind of remind you about this because remember, we looked at a curve earlier, right? We looked at it. So this is, does anybody know what this graph, the original, what is it going to look like? It's a parabola. It's a parabola. So I don't know really for sure if it's exactly like this, but I know it kind of resembles this, right? Is this always going to represent the tangent line? No, because look, for instance, here at this point, it looks like it's positive, right? Here at this point, I can already tell you it's negative. So obviously this is not going to be the right equation, correct? So remember, when you're finding these things, you're finding the equation of the lines at a certain point. It's at a certain point, okay? This is the slope everywhere, but those equations of the lines are at a certain point, okay? Any questions about this one? All right, so this is what, going back to like algebra 1, you had to remember stuff like that, right? Whoa. Okay, this is very important. This is very important. These are your rules. These are the derivative rules for your trig functions. There is no like, oh, let me just do it mathematically, algebraically. Nope. You just have to memorize them. You just have to remember them. Okay? So, according to this, the derivative of sine is equal to what? Cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared of x. The derivative of cosecant is negative cosecant cotangent. Secant is secant tangent. And derivative of cotangent is negative cosecant squared. So I'm going to give you some time to copy that down because you... quick, what is that? How does it look when we actually take the derivative? So I have a quick little example here. So if I tell you that y is equal to 6x squared plus 5 cosine of x, and I want you just to take the derivative, right? Now remember our rule. Because something is being added or subtracted, I can just do piece by piece, right? So for the first piece, what's the derivative going to be? Just 12x. Everybody agree with that? Okay. Now for the second piece, it's 5 cosine. What do I do with that 5? So, well, what do I do with it? Do you remember? I leave it. Remember your constant rule that you wrote at the very beginning? The constant rule said, look, if you have a constant times some function and they're asking you to take the derivative, basically just leave the constant and take the derivative of that function, right? So that's exactly what I'm going to do here. I'm saying, look, I know that there's a 5 in front of this cosine, but I'm almost going to ignore it for a little bit. And then I'm asking you, what's the derivative of cosine? Negative sine. So the only thing that's going to change, see how it was plus 5, but because it's a negative sign, I'm going to make this into a what? Negative 5 sine of x. And that's it. Okay? Negative 5 sine of x. Okay? Any questions on that? Alright, so guys, we're going to use these from here on out all the time. Okay, so you just have to memorize them. Just have to memorize them. I don't expect you to have them memorized in the next 5 minutes, but pretty close. Maybe 6 minutes. Got it? Alright. Let's keep trying. Let's keep trying. So say I give you a function that looks like this. Say I give you a function that looks like this. So I have the cubed root of x squared parentheses 2x minus x squared. Okay? Students look at these and they freak out. Okay? Because they look more difficult than they actually are. Guys, what is this our friend up here doing? What is it doing? It's being multiplied. It's being multiplied. So first of all, can I use it the way it is? No, I'm going to change it to what? X to the 2/3. So x to the 2/3. And then 2x minus x squared. So it is being multiplied. So before I take the derivative, what do you think I should do? Multiply it out and simplify it, right? So multiply it out and actually simplify. So I'm going to basically distribute this. How do you distribute x's? What do you do when you multiply x's? You add the exponents. Does everybody remember that? You add the exponents. So what is this going to become? 2x, and then you're adding what? 2/3 plus 1, 5/3. So you want to leave it as an improper fraction. So 5/3. Agreed? Okay. And then minus. So 2/3 plus. What do I got to do when I'm adding fractions? They have to have common denominators. So you don't think of this as 2, you think of it as what, Jordan? 6/3. Everybody got that? Right? So I'm not thinking of this as 2, I'm thinking of this as 6/3 because it has to be over 3. So what's 2/3 plus 6/3? So it's x to the 8/3. You with me? Now I haven't even done the derivative yet, right? I haven't even done the derivative. That was just my equation. So now let's actually do the derivative. Let's actually do the derivative. So, what am I going to do? So 5/3 times what? What's 5/3 times 2? 10/3, right? 10/3. So 10 over 3, x to the... Now when I'm subtracting 1 from 5/3, do I think of it as 1? What do I think of it as? 3 over 3. So what's 5/3 minus 3 over 3? 2/3. So you get 2/3. Okay? Minus 8/3. X to the 5/3. Fractions, guys. They're our friends. Okay? Don't be afraid of them. Know how to use them. Know how to use them. If you still don't understand how to multiply, add, or subtract fractions, come to me. I can give you some elementary school homework to do because that's where it's from. Is that my final answer? Is that okay to leave it like that? No. What do I got to do? Put it back in radical form because that's the way the question was asked. So what is my radical form? Well, 10/3 first. So the 10/3 is not inside the root. 10/3 is not inside the root. So it's 10/3 cubed root of x squared minus 8/3 cubed root of x to the 5th. It looks crazy, right? It looks ridiculous. Like I said, my favorite part about this stuff is when an administrator or another teacher walks in and they look at the board and they just freak out because it's like chicken scratch to them, right? But it's actually really, it's pretty simple if you're just following along, right? All we did here was multiply, add, and subtract, right? I mean, that's what calculus is. Multiply, add, and subtract. That's all we're doing, okay? Now, second one looks even more difficult because it's a what? It's a fraction, right? It looks even more difficult. So the ones that took BC last year, you're probably thinking, oh, he's going to talk about the quotient rule, right? Because there's a rule called the quotient rule. It's one of our derivative rules. We're going to learn it. But actually, guys, before you jump the gun, you don't have to use the quotient rule in this case. You don't have to use the quotient rule. Why? You have to understand the basics, guys. Anytime you're dividing something, and you're dividing an expression or an equation divided by one thing, does everybody realize that it's essentially every little bit divided by that thing separately, right? right? It's kind of like when you were in Algebra 1 and I said, remember, whatever you do to one side, you have to do to everything on the other side. Correct? And so does everybody agree that I can essentially think of my equation like this, right? Instead of it all over t squared, I can think of every little bit over t squared. Now, why does that even help? Because look, if I have 2t to the 5th over t squared, what do I know is going to happen here? You're going to subtract the exponents, or essentially 2 of the t's are going to cancel. They're going to go away. So this is really going to become what? 2t to the 3rd power. And then what actually happens here? This turns into a 1 plus 1. And then here, nothing's going to cancel in the end, but I at least have to do what so that I can actually use the power rule? Move it to the top. So this will become what? Minus 5t to the negative 2. Now, do you realize that this is the same exact equation? Just much simpler. Now it's in a form that I can actually take the power rule of, right? So now take the power rule. So h prime of t is what? 6t squared. 6t squared. And then what happens to the 1? It's 0, right? So nothing. And then plus 10t to the negative 3. And again, my final answer is, all I have to do is what? So it's going to be plus 10 over t cubed. 10 over t cubed. Are we good? Okay. Can I go? Any questions? Stop me if you have a question. All right, here we go. So now, here gets to the fun stuff. Here's actually saying, all right, fine. What, I know how to find a derivative, but how does that help me use a derivative? Okay, so here's some basic info, or here's some basic stuff. It says here, is f of x equals 2x cubed plus 300 over x cubed plus 4 increasing, decreasing, or not changing at x equals negative 2? Okay? Is it increasing, decreasing, or not changing at x equals negative 2? Okay? So, first of all, how can I tell if a function is increasing, decreasing, or not changing without the graph? So, all you have to do, guys, here's your key. Because remember, the derivative of a function determines increasing, decreasing, or no change when it is positive, negative, or 0, respectively. Okay? So the derivative of a function determines whether it is increasing, decreasing, or no change at all when it's positive, negative, or 0. So when they're asking, hey, is the function increasing? They're asking me, is the derivative positive? If they're saying, hey, is the function decreasing? They're asking me, is the derivative negative? And then no change, remember, we're finding slope of a tangent line. Slope is called rate of change, right? How it's changing. No change means that the slope would be what? 0. So here's what they're asking. They're saying, look, take the derivative of this, and tell me, basically, is the answer at x equals negative 2, remember, because it has to be at a certain point, at x equals negative 2, is the number positive, negative, or 0? That's it. Okay? That's simple. So that's what I'm going to do. I'm going to say, fine, let me at least take the derivative. Before I take the derivative, do I have to do any changes to my equation? Yeah, this middle term, right? I got to bring it to the top. So what is my real equation? Okay, so that's my equation. Now what's the derivative? right? And then, oh, and Jasmine's saying, well, really, it's 6x squared minus 900 over x to the positive fourth, correct? That is my derivative, right? So what do I need, though? They're asking me at the point of negative 2. So I need this. I need f prime of negative 2. So you have calculators. You don't have to do it by hand. So plug in negative 2. Plug in negative 2. So 6x squared minus 900 over x to the fourth. What is the answer when x is negative 2? Do we have calculators? Get one. Hurry up. What do you got? 129 over 4. Do I really care about the number itself? I care that it's what? Positive, negative, or 0. I care that it's positive, negative, or 0. So according to this, since it's negative, what does that tell me? It's decreasing. So here's your final answer. I can't spell at x equals negative 2, f of x is doing what? Is decreasing. And then because we're learning, because f prime of negative 2 is negative. Simple as that. So now, you don't even have to look at a picture and tell me, oh, I can tell you that it's increasing from here to here, whatever, because all you have to do is take the derivative and say, oh, it's positive, it's negative, or it's 0. Simple as that. We good? Any questions? You sure? I feel like this is too easy, yeah? Okay. Something we already did. Okay, let's try it again. This time I'm going to throw a little radical at you. So it says, find the equation of the tangent line 2f of x equals 4x minus 8 square root of x at x equals 16. Okay? So remember that rule I gave you. The equation of the tangent line is y equals f of a plus f prime of a times x minus a. Okay? Y equals f of a plus f prime of a x minus a. X minus a. So what's my a in this case? 16. Can you tell me my f of a? Bless you. Bless you. Can you tell me my f of a? What does that mean? What's y when x is what? 16. So this time, you know how in the last one they actually gave us the point and I didn't have to plug in, but this time did they give me the y? No, so you're actually going to have to plug in. Okay, so just real quick, you're going to plug in this equation, 4 times 16 minus 8 times the square root of 16, and what do you get? 4? Oh, I'm asking you to plug it in here. Right, so I'm asking you 4 times 16 minus 8 square root of 16, and you get what? 32. And then the only other thing I need for this formula is what? F prime of a. Okay, so I need to do what? I need to find the derivative. So here's my f of x. F of x is equal to 4x minus 8 square root of x. Before I get started, what? So it's 4x minus 8x to the half. All right, let's do its derivative. Let's do the derivative. What's the derivative of that? 4 minus 4 x to the it's 1/2 minus 1 Negative 1/2. Negative 1/2. Okay? So then really this is what? Ooh. So you don't, so it's 4 minus 4 over square root of x. 4 minus 4 square root of x. So that's my derivative. What do I need to do now? Plug in a, and what's my a? 16. So f prime of 16 is 4 minus 4 over square root of 16. We could probably do this in our heads. What's the square root of 16? 4 over 4 is? 4 minus 1 is? 3. Look at us, bunch of geniuses up in here. So now, do I have all I need? Okay, so then what is it going to be? Y equals? Try that again. Because it's 32 plus 3 x minus 16. Guys, I'm gonna be honest with you. On the AP test, this is a perfectly acceptable answer. Okay? If y is by itself, you're good. Okay? So I can, if I wanted to, do what? Distribute and simplify. There's nothing wrong with that. But this is a perfectly acceptable answer on the free response portion. Okay? On the free response, if you wrote it like this, you're done. Why? Because you're saving time by not simplifying. Remember, this is going to be a timed test. Any questions so far? Yes. A, yeah, it's the x. This is my x. So a is just whatever x they give you. Okay? All right, last one. Let's talk physics. Let's talk physics. Kinda. It says here, the position of an object at any time t in hours is given by s of t is equal to 2t cubed minus 21t squared plus 60t minus 10. Determine whether the object is moving to the right, or determine when the object is moving to the right and when the object is moving to the left. When is the object moving to the right? When is the object moving to the left? Ideas? Because remember at the very beginning I told you, no, not that. But the definition of derivative, it finds what? The slope of a tangent line, it finds the instantaneous rate of change, and it finds velocity. This is essentially velocity, because what is this object doing? Moving. Okay? It's moving. Does everybody see that? So this is a velocity question. So basically that means take the derivative, right? Take the derivative. So here's my question. How are you going to know that it's moving right versus it's moving left? Simple as that. Okay? Positive, negative. So does everybody agree moving right equals positive? Moving left equals negative. I have a question though, and it's really, really, really important that you understand this. How can an object go from left to right? Okay? At a certain point, it has to what? It has to stop. Does everybody understand that? Right? Because any object in our universe so far, right? In order for me to change directions, eventually I have to do what? Stop. Even if it's for a small second. Correct? Think about your car. If you're in drive, you're going forward, and then you go to reverse, it's not instantaneous. There comes to a point where you're like, stop, and then you go. Right? And then you go. So, you have to remember. So, if I'm talking about that, what do you think the stop looks like? 0. Okay? Stop is equal to 0. So, I have to not only do I have to understand when it's positive, when it's negative, but I have to understand when is it stopping. Because do you guys notice that it's not giving me any x's? It's not saying here at this time like it has before. It's saying you tell me when. Okay? You tell me when. So what we're going to do, guys, first of all, is take the derivative. Does everybody agree with that? We are going to take the derivative. So let's do that first. 2t cubed minus 21t squared plus 60t minus 10. Okay, let's take the derivative. 16t squared minus 42t plus 60. Okay? Oh, it's 6, right? You said 60. And I just wrote down. I trusted you, Caesar. I trusted you. Okay? We good? So, now. So how do you think I should start this? Good. Why don't I figure out where it's stopping first? Because I know where it's stopping isn't that it's going to change at some point, correct? It's going to change. So let's figure out where it's stopping. And we said stopping is equal to what? 0. So you're telling me that 6t squared minus 42t plus 60 equals to 0. That'll help me at least find the stopping points, correct? That'll help me at least find the stopping points. So how do I do this? Say that again. How do I do this? Oh, I thought you said it. Someone? You're going to factor. You're going to factor. Factoring helps. Actually, before I even factor, can I reduce it? I can reduce this. These are all divisible by what? 6. So if I take out that 6, what's left? T squared minus 7t plus 10 equals to 0. So now, students are always confused about, not confused, but they have this question. So does that mean that eventually I have to put this 6 back? No, absolutely not, because I took it out. Okay. Now I have to bring it along for the ride, meaning that there is still going to be a 6 here when I actually factor. Okay. But when I separate and solve, I don't really care about that 6, because think about it. Even if I did put the 6 back, wouldn't I just divide everything? Everything's just going to be 6 times bigger, and eventually it would just get 6 times smaller. So you're kind of saving yourself that headache. So here, what am I looking for? Factors of what? 1 times 10 is 10. Factors of positive 10 that add up to negative 7. What do you got? Negative 5 and negative 2. Negative 5 and negative 2. And then what goes here? In this, remember, it should always be what? Whatever your a is, but in our case, a is what? So t is equal to 5 and t is equal to 2. And I know they're equal to 0, so can y'all tell me the 2 times already? T is equal to positive 5 and t is equal to positive 2. What does this represent? These are my stops. So you have to understand, these are the times when object stops. These are the times when my object stops. So I'm going to set up a nice little number line over here. I'm going to set up a nice little number line. So I know this is 2 and this is 5. And I know here my derivatives are 0 at those 2 points, right? And what else do you think I'm going to try and do now? Because it asked me for when is it moving right and when is it moving left. Yeah, so what I'm going to do, guys, at this point is I'm going to test. Because I know it stops here, right? I know it stops here, but I'm going to test, okay? Now, don't go nuts, because all I have to do is test any point to the left. Okay? So I actually want to add something here. What points am I... Because what's to the left of 2? Everything. 1, 0, negative 1, negative 2, except one thing. What can I not test in this case? Now, I can test 0. I can't test negatives. Why? Why can I not test negatives? What does t represent? Time. No such thing as negative times. Everybody got that? Okay, so I am not going to test a negative. But guys, make it easy on yourself. Let's test what? 1. Let's test 1. That's going to be easy. So if I plug in... Now, do I care about the value of 1? No. All I care is that it's what? Positive or negative. So, f prime of 1 is what? When I plug in 1 over here. When I plug in 1 to my derivative. You can use your calculator. So Plug in 1. So 6, 1 squared, minus 42 times 1 plus 60. Huh? Yes. So more specifically, that's a what? That's positive. So does everybody agree that f prime of 1 is greater than 0? It's positive? Right? So it's positive, which tells me automatically that this is moving to the right. It's moving to the right. Now, yes, from 0 to 2, it's moving to the right. Correct? Now, tests here. What do you think I should test here? Or what can I test? 3 or 4? It's up to you, so you choose one. I don't really care. Which one do y'all want to test? Okay, so f prime of 3. So 6 3 squared minus 4 3 plus 60. 72 is positive? Yeah. Negative 12. So then this is less than 0, so it is negative. So then what does that tell me? It's going left. And then you can kind of figure out, or you can kind of guess what do you think is going to happen over here, but you still have to test. Okay, so I still need you to test, because is it possible that my object stopped but kept going in the same direction? Very possible. I mean, we do it all the time, right? So you still need to test. So probably you can test 6, but you can test anything. You could test 100 if you wanted to, right? Anything bigger than 5. So what do you get? What do you get? It's a positive. So then that tells me that it's what? It's moving right. Okay, it's kind of what we figured, but you know, we still have to test. You still have to test. You can't just assume, right? So then in the end, the question was determine when the object is moving left or moving right and moving left. So you have to actually specify. Look, it's moving right when. So there's two ways, because you can put it in either interval notation or inequality or whatever. So I prefer interval notation. Does everybody understand when I say interval? It's with the brackets and the parentheses and all that. So from where to where is it moving to the right? From 0 to 2. Oh, yeah, exactly. So good point. So she's saying, wouldn't it be parentheses? So why can I not include 2? Because at 2, it's actually not moving right. It's 0, right? It stops. So from 0 to 2, and then that's my union symbol, and from what? 5 to infinity, right? So it's going to be moving right the whole time. It's going to be moving right the whole time after 5. And then it's moving left when? How do I write that? Parentheses 2 to 5. Okay? So this is how you would express this answer. So before I stop, I do want to recap. Does everybody understand what we did? So we had an object, right? And they gave us a function for that object. And the question was determine whether it was moving right or left, okay? And to us, that meant if it's moving right, that meant that it's what? What's positive? More specific, the derivative. The derivative, because derivative explains velocity of an object at a certain time. You wrote it down in your definition on the first day. So if it's moving right, I knew that the derivative had to be positive. If it was moving left, I knew the derivative had to be negative. But because it's moving left and right, I did also have to consider that at certain points it's going to what? Stop. And according to, if it's stopping, then I know its derivative is equal to what? 0. So these are the important parts. And then we just did the algebra. Fine, here's my function. Here's my derivative, 6t squared minus 42t plus 60. If I wanted to find out where it stops, what did I have to do? Set it equal to 0, solve, right? Set it equal to 0, solve. Am I always going to be able to factor, by the way? No, do you remember what you use if you can't factor? Quadratic formula, right? Remember this guy? The quadratic formula. This works all the time. You can even use this even if you can factor, and it'll still give you the answers. But that's what it does. It finds your zeros, right, of a function. So I factored. I found out that t equals 5 and t equals 2. What did these represent? the stops, okay? The stops. So I know that these are the times when it stopped at t equals 2 and t equals 5. So I set up a nice little number line, and then what did I have to do? Test. You had to test around those points. I don't have to test those points because I already know they're zeros, right? So I test around the points. Be careful when you're dealing with time, because what is there? There's no negative, so it has to be greater than 0. Okay, because some students say, oh, let me test -1. But you can't, not when you're dealing with time. Okay? Any questions on derivatives? Okay, so the first day was kind of easy. Power rule, right? Just, oh, let me just do all that. And yes, that's the way you find a derivative, but what's more importantly is not how you find it, or that you can find it, is can you apply it? Okay, can you apply it? So do you understand why we do derivatives? So notice that we're starting to get, this is more real world, right? So everybody always asks, well, what's the point of calculus, or what's the point of math? And this is the point, right? This is the point. I mean, think about, this is something that somebody uses in space, right? You see an asteroid, you can figure out when it's going to change directions, which is pretty important if it's heading towards Earth, correct? Any questions about power rule or derivatives, day one calculus stuff? Fantastic. Let us